This is AP Calculus. We are talking about the Unit 2 pretest. I'm going to try to go over every single problem. I think we have enough time. There's 20 questions. We basically have 50 minutes. I mean, we have the entire period. Claire's not here today, so this video is for you, Claire, and anyone else that's in the future. So this is going to be I'll do this in, blue sounds good. So this is going to be our key. This key was made in 2019, just in case it was a later date. Alright, number one, usually I always make number one on the pretest and test the hardest question. This one is tricky. This is the definition of the derivative, but just a different form. Usually we have as h goes to 0. This is making it so that the bottom goes to 0. So definition of the derivative, again, means that you're taking the derivative. Do any of these say derivative in them? Oh, let's see. So that is just kind of hard to see. It is just a second definition of the derivative. You need to know 3 of them to know all of them. As long as you know one of them, you're good. If you do your hot boxing, I guess you can say there's your hot box. You can scribble out the inside, but there it is. It's just f of x. So it's the derivative of f of x, and your c happens to be right there in this case. So that was your c. So it's the derivative of f at x equals 2, and we know that the derivative is equal to 0, so that's why it says it is 0. Slightly different there. I don't expect you guys to be able to get that guy. That was the tricky one. But everything else is kind of straightforward. Well, maybe not all of them are straightforward, but yeah, that was the hardest one on the test, I think. Number 2. And this is also another definition of the derivative because I have h goes to 0, so I'm going to hotbox this. I'm going to do the top left, turn that into a box. The thing added to h is my c, so my c is going to be equal to e, which is 2.7182818, stuff like that. I'm going to scribble out the inside, change that to an x, so our function, our f of x, is really the natural log of x.
It's equal to the natural log of x, right?
Yep, and then I need to take the derivative, so I'm going to do f prime of x. When I take the derivative, derivative of natural log house is 1 over whatever the inner was, so 1 over x. There's no dinner here. If I do dinner, it's just times 1, so I don't have to worry about it. The derivative of x is just 1. And now I need to plug in c, so this is going to be f prime of e. I'm plugging in e. When I plug in e, it's going to be 1 over e. So 1 over e, and I don't even need to take the derivative. It's just saying you take the derivative and plug in e, so f prime of e, don't do those, not that, not that. These both say f prime of e, so that's why I'm paying attention to them. And then from there, I'm looking for f of x is equal to natural log of x. There's the correct function. I didn't even have to do all that work, Mr. Sindel. Correct answer was A. Moving on to number 3. So we need to take the derivative of all those things. So this is kind of like where you take the derivative and you distribute it into each of those. So I'm going to take the derivative of each of these in term. So I'm going to really take the derivative d with respect to x, and that's going to be of x to the power of negative 3. I can't really deal with a fraction, so I need to convert these all. And then I'm going to take the derivative of x to the negative 1, and this is still plus x squared. I don't have to change that last one. I do have to change all of these. So if you see a fraction, you need to change them to negative powers. From here, I'm going to actually take the derivative. This is powerhouse for each of them. Powerhouse, 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 powerhouse says, yeah, Gio?
When you did that, when you took the derivative, that's the derivatives right there, right?
No, I haven't taken the derivative yet.
Okay.
I've just changed it to the form. So this x went up here, and then I changed it to a negative power. Now I'm taking the derivative. The negative 3 is going to come down in front, so it's going to be negative 3x, and this was negative 3, but I'm going to subtract 1, and it's now negative 4. There it is. Again, I'm going to bring that negative 1 down in front. Negative 1 times negative 1 is now positive x, and then it was a negative 1. I'm going to subtract 1, and I get negative 2, and then I'm going to do the same thing. Powerhouse, the 2 comes down in front, so 2x, and then subtract 1 to the power of 1. I didn't even need to write the 1. I just did it to be clear. And as soon as I take the derivative, I'm going to immediately plug in negative 1. So if I plug in negative 1 now, I'm going to get negative 3 times negative 1 to the power of negative 4 plus negative 1 to the power of negative 2 plus 2 times negative 1 to the power of 1. So the general rule of thumb is whenever, it doesn't matter if it's negative or positive, whenever I have an even power, negative to an even power is always positive. A negative to an odd power is negative. If you don't know that rule, write it down. It's a quick little shortcut. If I have a negative to the power of an even, that's always going to be a positive. If I have a negative to the power of an odd, that will always be negative. Our quick little shortcut. It doesn't matter if it's positive or negative. This was a negative to the power of an even, which means that is positive, and it becomes a positive time, or positive 1 times a negative 3, and we get there a negative 3. Again, a negative to an even is a positive, so positive 1 plus 1. And then a 2 times negative 1 is just negative 2. I'll pause there and make sure we really understand what's going on. We're going to study really hardcore tonight. We're going to do the pretest again, all of us, right?
100%.
Good, all right. A negative 3 plus 1 is a negative 2. Negative 2 minus 2 is a negative 4. The correct answer here is B, negative 4. I can write down negative 4 here as well. Negative 4. All right. If at any time you guys need to ask questions or make me slow down, that's where you're raising your hand, but because you are not doing that, I am moving on to number 4. So I have these functions, I have their derivatives and everything listed. I need to do this guy. So this guy's was pretty hard. It's chain rule. It's Dowder times dinner. It's always Dowder times dinner. It just looks weird. So H is this thing. I'm taking H, and I'm taking the derivative of that, and then I'm going to plug in 1. That's what I'm saying. Derivative is always Dowder times dinner. Dowder times dinner. Dowder times dinner. Well, Dowder. Outer is F. This guy is outer. O-U-T-E-R. Inner is this G of X. That is our inner. So if I'm doing the correct math, I should be doing Dowder, D outer, times your dinner, D inner. If I'm doing that correctly, then we're going to be using these values, and we'll see what happens. So, Dowder, the derivative of the outer. The derivative of the outer, well, outer is F, so the derivative of F is F prime. F prime. And you leave the inner. The inner stays the same. So it's still inner, G of X. That was Dowder. This whole thing right here is Dowder, the derivative of the outer. I need to now multiply that by dinner. Well, dinner is, let's see, inner. Inner is G of X, so I need to take the derivative of G of X. That's G prime of X. G prime of X. This thing is our dinner. We're going to eat him. Well, now I've figured out what the derivative is. I mean, it looks kind of gross, but there it is. And I'm going to plug in 1. So let's do that. If I plug in 1, I'm going to turn this into F prime of G of 1. A little bit of lag there. G of 1 times G prime of 1. Let's go ahead and simplify this stuff on the left first. What is G of 1? I'm dealing with just this inner right here. What is G of 1? We'll come back over here. G of 1 is 3. So this turns into F prime of 3 times, well, what's G prime of 1? Come back over here. G prime of 1, there you are. G prime of 1 is negative 3. Negative 3. The next question becomes, well, what is F prime of 3? F prime of 3, if I look at this guy, F prime of 3 is right here, negative 5. So I get negative 5, this is equal to negative 5 times negative 3, which is equal to a positive 15. Correct answer is B.
Wait, how do you got the prime of F prime again?
So F prime, you're coming all the way back to this step, right?
Yeah, but like
This F prime comes from Dowder, the derivative of the outer.
but I'm asking where you got F prime of 3. How you got that?
So G of 1. What did G of 1 turn into? What is G of 1? I come back over here. G of 1.
Oh, okay. I didn't see that.
Perfect. Good question. Keep asking questions. I love those questions. That means that you're paying attention. That means you're trying. I love people that try and pay attention. I love them more than people that think that they're smart. Because if you are hardworking, that's just setting you up for success for the rest of your life. And it is kind of a fun question. If you see it again, now you know how to approach it. And I'm pretty sure there's almost an exact same question with different numbers on the test. So know how to do number 4. Number 5. So if we have this e to the power of 1 over x for our function, then I'm taking the derivative. So we know that 1 over x can be rewritten as x to the power of negative 1. Which means if I'm rewriting f of x can be rewritten as e to the power of, instead of to the power of 1 over x, it's now to the power of x to the negative 1. So e to the power of x to the power of negative 1. So there's like a tree here of powers. I don't like fractions. Fractions make me cringe. It means I have to use quotient rule, which is really hard. It means I have to do really weird things. I don't want to use quotient rule, so get rid of the fraction by rewriting it with the negative power. Now I can take the derivative. So when I take the derivative, let's switch colors here. When I take the derivative, I now have f prime of x. The derivative of e house is e house, exactly. It's the easiest one. So the derivative is e house, e to the x to the negative 1. But I now need to do dinner. That was Doubter. Doubter is always easy. You guys know how to do the rules for Doubter. Now I need to do dinner.
Is it just one, right?
The inner is x to the power of negative 1, which is a powerhouse.
-1, and then, right?
So the negative 1 comes down in front. I agree. The negative 1 comes down in front, and I still have x
X to the negative power.
to the negative 2. I subtract 1. Now I need to reduce and simplify into one of these 5 forms. So when I do that now, let's switch to yellow. This e to the x to the negative 1, x to the negative 1, we know that converted back to 1 over x. So I'm going to convert that back. This is now e to the 1 over x power. Now I'm going to reduce, or I'm going to simplify this negative 1 over x. And actually, all this is being multiplied, so I can just make this a negative out front. Oh, I'm already done. Well, not done. I know it's not c, d, and e, just from the fact that there's no negative out front. There should be a negative out front because I have a negative 1 here. Now I need to say this is all being divided by x to the power of 2 because this x to the negative 2 comes down to the denominator. The exponent becomes positive, and we have our final answer. There it is, A.
So you don't have to put the -1 in front. Because
You do have to put the negative 1 in front. I just left it negative in front instead of negative 1 because negative 1 is the same thing as just negative. Yeah. Good question. Other questions? Other questions? We're moving on to number 6 then. So flip it over. So, we immediately see h goes to 0. I'm thinking definition of the derivative. I'm immediately then thinking hotbox. So let's hotbox this question. There's our box. It's pretty hot. That means that my c is equal to 2. I know that if I scribble this out and change it into an x, my f of x function is just f of x. It's just there. There's no function. It's just f of x. And I know that when I take the derivative, when I do f prime and I plug in my c, when I do all of the final operations, I know that the answer is 5. So this is really saying, if I'm being very formal, that's saying that f prime of 2 is equal to 5. That's all the information that is given inside this definition of the derivative. If I take the derivative of f and I plug in 2, the derivative or the slope is 5. So now I'm asking, which of the following have to be true? They have to be true. Well, is it continuous? If I take the derivative, am I continuous? Yes. If I'm differentiable, if I'm taking the derivative, I automatically am continuous. So this is true. Because, and you can say because here, differentiable, if I'm differentiable, if I can take the derivative, that always implies that I'm also continuous. I can't take the derivative if I'm not continuous. All right, number 2, f is differentiable at x equals 2. Well, there it is. I took the derivative at 2. Look at this line right here. I took the derivative at 2, so I must be differentiable at 2. That's kind of what you're literally saying on this line. You are differentiable at 2. Not only are you differentiable, but we found the derivative and it's 5. So true. Just look over here. I'm just going to draw an arrow. There it is. And 3, the derivative of f is continuous at 2. Well, this is a little bit different. It's saying that the derivative is continuous. Not that f is continuous, but that the derivative is continuous. And we don't know that. We don't know if the left limit and the right limit are equal to each other. This is true by the differentiability test, where it's kind of like the continuity test, where you do the limit, I should say, the left slope equals right slope equals the actual slope. But we don't know the left and right slope. We know what the actual slope is. The actual slope is 5, but we don't know what the left and right slope are. We don't know the limit as x approaches 2 from the left of f prime is. I'm being very informal by saying left slope. If you want to be more formal, I'll do this as a note. You don't have to write this, but you can say the limit as x approaches 2 from the negative side of f prime, f f prime of x. I didn't want to have to write all that out, but that's really what I'm saying by left slope. We don't have the left slope. We don't have the right slope. We don't know 3. It's just 1 and 2. Correct answer is C. All right. On to number 7. All right. I'm taking cosine of 4x. I don't have 2 variables. I only have 1 variable, so there's no product rule yet. I'm just taking cosine of 4x, and then I'm going to cube that. Again, if I'm rewriting this to make this make more sense, this can be rewritten as cosine of 4x, and then after I take cosine of 4x, that whole thing, I'll put it in square brackets to make it even clearer, that whole thing is going to be cubed. That's another way to write it. So the most outer thing is this power. That's the first thing I'm going to deal with when I'm taking the derivative. It's powerhouse. Powerhouse says 3 comes down in front. This is now equal to 3 comes down in front times cosine of 4x. The inner stays the same. Don't change the inner. But now instead of a 3, this is going to go down, subtract 1 to a power of 2. Don't forget your dinner. This right here was doubter. I need to now multiply by dinner. So careful here. Dinner is cosine. The inner is cosine of 4x. So when I take dinner, I'm taking the derivative of cosine. Cosine switches a sign.
It's
Negative? Is it negative sign?
And it is going to be negative because C stands for change, and it turns into a negative sign of, again, I have an inner, which is 4x. I can't touch him yet. Now I can multiply by my inner, the derivative of the inner, the derivative of 4x, which is 4. And then multiply those all together. I have a 3, a negative, a 4. 4 times 3 is 12. The negative makes it a negative 12. Switch colors here. It's a negative 12, blah, blah, blah. I don't even care at that point. Look at this. Multiple choice questions. Which one starts with a negative 12? Not A, not C, not D, not E. B is the only one that starts with negative 12. I don't even need to simplify this. I can do it for the notes if you want it, though. It should be 12 cosine squared of 4x. Again, this 2 can come and I can put it right here after the cosine. You're allowed to do that. It's a little bit more formal. And that's all times, I guess I can just squish it next to each other, sine of 4x. I guess I'm literally rewriting B at that point. All right, no hands, which means I'm going to move on to number 8. Number 8. So we have f of x is equal to this piecewise functional, and we know that it's differentiable, which means it passes the continuity test and the differentiability test. Both of those tests say set the left side equal to the right side equal to the actual height, or left side equal to the right side equal to the derivative or the slope. So I'm going to set them equal to one another. I'm going to set the left piece, e to the negative x plus 2. I'm going to set that equal to the right piece, which is also the actual height, equal to ax plus b. And I'm going to plug in the suspect point for x. Not for a and b, just for x. So 0. So this is going to be now, I'll switch colors. I'll leave blue. E to the 0 plus 2 must be equal to a times 0 plus b. If I simplify that, anything to the power of 0, including e, is 1. So this is going to be 1 plus 2 is equal to 0 plus b, which means b is equal to 3. We're halfway there. We use the continuity test to do that. We now need to use the differentiability test, which means I take the derivative of the left, derivative of the right, and then set those two equal to each other. So before I do that, let's go ahead and write it out. What is f prime of x? That should be equal to a piecewise function. Take the derivative of the top or the left piece. Derivative of e house is e house, e to the negative x. But don't forget your dinner. By the way, derivative of a constant is 0. That one goes away. Derivative of the inner. The inner is negative x, so the derivative of negative x is
1.
Multiplied by negative 1. So there's the left piece, or the top function that you see here. The bottom function, the right piece, I need to take the derivative of it, and that is just, you can think of it as powerhouse, it's just a. Why is it a, you might ask? Well, the derivative of b, that's just a constant. B can be like 7. Some number, some constant, that goes to 0.
So the x doesn't go with the a?
The x doesn't go with the a, and here's the reason why. If I have ax to the 1, and I take the derivative, this turns into, the 1 comes down in front, 1 times a is just a. We all agree that 1 times a is a. And then this x to the power of, it goes down a power. 1 minus 1 is 0. Anything to the power of 0 is 1, so it's just a. If there's a squared, then you still have an x. Yeah. It's always powerhouse. Even if it's just an x, it's still using powerhouse. Okay, now I'm going to set the left and the right things equal to each other, plug in the suspect point, very similar to what we did on the left-hand side with the continuity test. Now with the differentiability test, we say e to the negative x, sorry, negative e to the negative x, because I still have that negative out front, should be equal to a, and I'm plugging in my suspect point. Negative e to the negative 0, which is just 0, is equal to a, and anything to this 0 is 1, so I have negative 1 is equal to a, and there it is. I have a and b. It's asking me to find a plus b. I need to add 3 and negative 1 to get 2. Correct answer is C.
Oh.
I stopped with the first one.
Oh, so you got
Like,
B.
I got 3.
Good, yeah, so you were halfway there. Yes, so for the test, just do the second half where you take the derivative of the left piece, derivative of the right piece, set those equal to each other. You do that whenever it tells you differentiable. If it only said continuous, we're only allowed to do this left-hand side. But because it's differentiable, we can do both. All right, and we're moving on to question number 9. I'm taking the derivative of a fraction. Gross, a fraction, I don't like it. I'm going to automatically change it. So I'm going to say that this is now the derivative. Oh, does it make sense? I'll change it eventually. Just note that if I want to change this, this is the same thing as x squared minus 1, all of that to the power of negative 1. I am allowed to change it. I don't like fractions. I like negative powers. They're much easier to do power rule from our powerhouse. But let's go ahead and just take the derivative as it is for now. So when I take the derivative of natural log turns into 1 over whatever the inner is. So this is going to be, let me write this a little bit clearer. It's 1 all over 1 over x squared minus 1. Another way of writing this, and I know I still need to do dinner out here. So this is just doubter, and I still need dinner. But before I talk about dinner, I should be thinking in my head, how do I solve that thing? Question, Gio?
That's the
Derivative?
That whole fraction.
Well, it's the derivative of a natural log, right?
Oh.
Derivative of natural log says do 1 over that.
Yeah.
So I did 1 over that. This is asking me, what is 1 divided by 1 over x squared minus 1, which is the same thing as 1 over 1 divided by x squared minus 1. This is a keep it, change it, flip it. If I keep it, change it, flip it, it's going to be 1 times x squared minus 1 all over 1, which is just x squared minus 1 over 1. But we forgot our dinner. We're going to starve. Let's talk about our dinner. This is our inner. We all agree that this thing that is just circled in green right here, this is our inner. I need to take the derivative of that. So dinner should be,
2x.
I'm going to bring this 1 down in front. Again, it's powerhouse. The 1 comes down in front. So it's going to be negative 1 times, inner stays the same. I can't touch the inner until I'm done with the outer. Still x squared minus 1, but now to the power of negative 2. Good. And we have an inner. Our inner is x squared minus 1. I can finally touch that guy. I can finally deal with him. Let's do dinner times times the derivative of this, which is
2x.
Good job, 2x.
Wait, but, oh, you put the 2 down, right?
Yep. You bring the 2 down, it goes x to the power of 1. I should switch all of this to blue so I'm consistent with my colors. And that was the first step. Doubter, dinner, inner.
So what you did in orange and green, does that matter?
It does matter because that's kind of like the second step. That was step number 1, and now I'm on step number 2 in yellow. Step number 2 is kind of simplifying this thing.
Okay.
This thing now turns into negative 1 on the top, all of this divided by x squared minus 1, but now to the power of 2. If I brought it down to the denominator, this negative 2 turns into a positive 2. And this thing can't be simplified, so I'm just going to leave it times 2x, I guess over 1, that makes it a little bit easier. So what I'm really doing now is I'm multiplying all 3 of these things together. When I multiply all 3 of these things together, when you're multiplying fractions, it's pretty straightforward. You don't even have to worry about common denominators. You just multiply straight through. On the top, I have
Negative x squared plus 1.
I have x squared minus 1 times negative 1, so I can put the negative out front, times 2x. That's on the top. I dealt with this guy, and this guy on the top. On the bottom, I have 1, 1, and this guy. So I really have to deal with just the x squared minus 1 quantity squared. So on the bottom, I have x squared minus 1 quantity squared. We're basically there. I just need to simplify it.
So it's going to be negative x squared plus 1.
Negative 2x.
Negative 2x squared.
So notice this. I have an x squared minus 1 on the top and the bottom. X squared minus 1 on the top and the bottom. So I'm going to cross off one of them on the bottom, shwink. Cross off one of them on the top, shwink. And I get negative 2x on the top and x squared minus 1 on the bottom. Let's search for that guy. There he is, B. All right, that was number 9. Lots and lots of algebra happening. And the derivative was kind of hard because we had to dinner inner. Let's go to number 10. Ooh, a table problem. All right. Ooh, and it's product rule. Ooh, man, this one is going to be fun. Okay, so we have tables that give f and f prime. It's very, very similar to, where was it? Number 4, where we had all of these values given, except they're being given in a table this time. They're being given in a table, and it gives us our h of x is equal to this thing. So we need to take the derivative. What do you guys see? I see, at least, a function, this function, and a second function being multiplied together. Product rule. Give me product rule. What is it?
We
1
1d2 plus 2d.
plus 2d1. High and low are reserved for when I have a fraction.
That's what I meant.
You're good. All right, so I'm assuming that 1 is this thing, and then 2 is this thing. So when I actually do my product rule, I'm going to do 1, which is 2 f of x plus 3. There's 1. I'm going to run out of room up here, aren't I? I'm going to move this guy down here. A little bit higher. There's 1, and then I'm going to multiply all of that 1 times the derivative of 2. Well, what's the derivative of 2? Well, the derivative of 1 is 0. It's a constant. And then I take the derivative of g of x, which is just g prime of x. So g prime of x. Those two got multiplied together. So I just did 1d2.
You're multiplying because they all what?
I'm multiplying because it says 1 times d2.
Oh, wait, don't supposed to be the first part of it supposed to be negative? This is a negative in front. Or that's an equal sign. Never mind.
Yeah, it's an equal sign. And then I'm going to add, just adding here, and then 2. So 2 is just this whole thing, 1 plus g of x, 1 plus g of x. That was 2. And then I need to multiply this by the derivative of 1. So the derivative of this guy. The derivative of that is going to be, well, I still have the 2 as a coefficient out front, so times 2. And then what is the derivative of f of x? F prime of x. There it is. We've taken the derivative of h of x. There it is. There's h prime of x. But it's not asking us for h prime of x. It's asking h prime of 1, which means I need to plug in 1. So if I'm plugging in 1, let's do that right now. It's going to be,
Question.
yeah.
Right here. So this is the first, and then the third, and then the second. So now, what? Like, how you got that part here?
All right. So explaining that. Okay. So 1 and 1.
Can we leave the door unlocked?
No, we can't.
People just keep coming in.
I know. It's really, really annoying. D2, there's the derivative of 2. Plus Plus
okay.
2, there's 2, and then the derivative of 1 is the derivative of 1. I think color coding this might help. So if I say that this stuff is in green and this stuff here is in green, that might solve some issues that we have. It's a little bit easier to see. All right, and then from there, I'm going to plug in 1, because it's saying h prime of 1. When I plug in 1, I'm going to get 2f of 1 plus 3, all of that times g prime of 1. All right, let's add in what happens when we multiply over here. When we multiply, or when we sub in over here, it's going to be 1 plus g of 1 times 2f prime of 1. All right, now we're using the table because I don't know what f of 1 is. So f of 1, If I plug in 1, f of 1 is 3. So this f of 1 right here turns into 3. 2 times 3 plus 3 is 9. So let's write down 9 times, and what's g prime of 1? G prime of 1 is 4.
Oh, just kidding.
There it is right there, 4. And then I'm going to add this to 1 plus g of 1. Let's figure out what g of 1 is. G of 1 is negative 3. So I'm adding negative 3 with 1, and I get negative 2. So this is going to be negative 2 times, let's do f prime of 1 first. F prime of 1 is negative 2. Negative 2 times 2 will give me negative 4. So I've simplified this into a nice little, I don't know, third grader problem. 9 times 4, this is going to be now equal to, I'll do it up here, that's going to be equal to 36 plus 8. Because negative 2 times negative 4 is positive 8, and 36 plus 8 is equal to, I'm running out of colors here, I'm going to go back to blue. That's going to be equal to 44. Correct answer is D.
No, for that you gotta be like really mean with it.
Yeah, you do.
Like mess yourself up.
There are many, many chances to go wrong. All right. We're doing good on time. We're halfway through our, oh no, we're 40% through our time. Okay, so we have to pick up the pace a little bit. Number 11. This is going to be product rule because I have an x and an x. So product rule, again, chat it out.
1d2.
And my 1 is x squared. The derivative of 2, the derivative of e to the x is just e to the x, plus 2d1. So I guess I should do all this in a separate color. I've learned my lesson. Color code your product rule. It makes it much clearer. Plus 2, which is e to the x, and then d1, which is 2x to the power of 1. And we're looking to simplify that. So when I simplify that, I can pull out an x, and I can pull out an e to the x. So if I pull out an x and an e to the power of x, what's left over? Well, there's one x gone, so there's x left over. So x plus, and then cross out that, I'm left with a 2. So plus 2, and where's our answer? There it is, C.
So for that you kind of just want to factor.
Yep, so product rule, then factor it out. Factor out the GCF. Number 12. Ooh, number 12. This comes up over and over and over on tests in the future, so know this one well. The functions of f and g are piecewise, shown above. We need h of x is equal to f of x over g of x. So when we take the derivative, we need quotient rule. I have a quotient here. I need quotient rule. Tell me what quotient rule is. There it is. Low d high minus high d low, all over low low. All over low low. All right, so it's going to really help us if we know what the derivative of all of these things are. So when I'm plugging in 3, let's come back up here. I'm going to switch gears. What is f of 3? And then what is f prime of 3? Next question I'm going to ask is what is what is g of 3? And what is g prime of 3? Well, f of 3 is the height at 3, right? So the height at 3, let's go to 3, and I go to f. The height at 3 is right here, which is 1. So f of 3 is 1. We can all nod our heads. We know what's going on. F prime of 3 is the slope at 3. So what is this slope of this line right here? Well, the slope, it goes down 1, right 3. So the slope is it positive or negative, first of all? The slope is negative. If I have a ball on the left and I roll downhill, I'm going to be rolling as a negative slope. So this is going to be negative something. And is it negative 3 or is it negative 1/3 for this slope right here?
1/3.
It is indeed negative 1/3. Let's do g. I'm talking about this function right here, g of x. The g of 3 is asking for the height at 3. Height at 3 is right here. The height of 3 is 3. It's right here. Height of 3 is just 3. G prime of 3 is a slope, and the slope goes right 1, up 1, right 1, up 1, right 1, up 1. It's nice and easy. It's just 1. Again, draw your steps if you need to figure out the slope. Step, draw your steps. So we have all the input. So now we're going to come back here and plug them in. So what is low? Low is g of x. So I'm going to say g of x times d high, the derivative of the top, which is f prime of x. Subtract. high, which is f of x, times the derivative of low, which is g prime of x. All of that is going to be divided by low, which is g of x, that quantity squared. We have what all of these are. We know what g of x are. We know what f prime of x are. We plug them in. When we plug them in, g of x is g of 3. G of 3 is 3. So this is now going to be equal to 3 times f prime. F prime is negative 1/3, negative 1/3. Minus, well, f is just 1. G prime is 1. 1 times 1. All that is going to be divided by g squared. So g is 3. 3 squared is, we'll only leave it 3 squared. It is 3 squared, which is 9. So now we have to simplify that even more. I'm going to move this to the left because we ran out of room. If I move that to the left, then I have room, and I can say, well, that's equal to 3 times negative 1/3 is negative 1 minus 1 all over 9, and that is equal to, you can do a keep change. So negative 1 plus negative 1 is indeed a negative 2 over 9. Negative 2/9 is our answer. Correct answer is A. All right. That was number 12. We're on to number 13. We have f of x is equal to this thing. I have a function here and a function here. I'm multiplying the functions. I am using product rule. Product rule, again, is 1 d2 plus 2 d1. What is 1? 1 is x minus 1 quantity squared. What is the derivative of 2? That is negative sine of x. I multiplied those two. And then I'm going to add 2d1. Well, 2 is just cosine of x. Cosine of x. And I'm going to multiply that by the derivative of 1. The derivative of 1 is going to be, I bring the 2 down in front because it's powerhouse. 2 comes down in front. And it's going to be 2 times x minus 1 still to the power of, it goes down a power, it was 2, it goes down to 1. And dinner is just 1. So don't forget your dinner. Dinner is 1 in this case, so I don't actually need dinner. I immediately plug in 0 because I'm saying f prime of 0. When I plug in 0, I get negative 1 squared times. When I plug in 0 here, sine of 0 is just 0, so this is going to be 0. Sine of 0 is 0. Then I'm going to add. Cosine of 0 is 1 times. If I plug in 0 here, I get 0 minus 1, which is negative 1. Negative 1 times 2 is a negative 2. So I'm going to get 1 squared, which is 1, plus negative 2. My correct answer is negative 1.
Wait, for the far right, you distribute the 2.
I do distribute to the 2. So, well, x is 0, right? 0 minus 1 is negative 1. Negative 1 times 2 is negative 2. Good question, good question. We have 11 minutes left of class, and we have 6 questions left. So I need to be doing these kind of quick now. I'm sorry, I'm going to have to run through them. You guys might not be able to catch up, but the video will be up online. I'm going in speed mode now. So this is going to be quotient rule because I have something divided by something. It's going to be low, d high, minus high, d low, all over low. When I do that, low is going to be x squared plus 1. That's going to be times the derivative of the top, which is just 1, minus high, which is x plus 3, times the derivative of the bottom. Derivative of low is 2x. All of that is going to be divided by the bottom squared, low, so x squared plus 1, quantity squared, and I'm going to immediately plug in a negative 2. When I do that, negative 2 squared is 4, plus 1 is 5, times 1 is 5. Minus, when I plug in negative 2 plus 1 is negative 1. It's going to be negative 1 times, when I plug in negative 2 here, it's going to be negative 4. All of this is going to be divided by, plugging in negative 2. Negative 2 squared is 4, plus 1 is 5. 5 squared.
What did you do with the 3?
The 3. Oh, why did I write x plus 1? It should be x plus 3. Yeah, teacher error. Catch it. Log it. This should be a 3. Don't know what was going on there. X plus 3, which changes things because this now comes and becomes negative 2. It becomes a positive 1 instead of a negative 1. So it should be a positive 1. Thank you, Arrow. 5 minus negative 4 is 5 plus 4. That's 9 over 25. And 9 over 25 is E. Sorry, you have to move on. Oh, these are some review problems from Unit 1 now. When I take the limit to infinity, these are the top-bottom rules. Cross off everything that's insignificant. Too small, too small, too small, too small. Take the coefficients. Negative 3 and a 2 becomes 2 over negative 3. Correct answer is A. That's from top-bottom rules. I'll write them out. Top-bottom rules. That's from Unit 1. Number 16. Again, a Unit 1 revision, or Unit 1 review, not revision. We know that it's continuous on the closed interval and it's differentiable. We have unlocked all three theorems, EVT, IVT, and MVT. So, which of the following statements could be false, which means most of them are true? All right, this is talking about height. Height is guaranteed by IVT. Is 0 in between negative 5 and 4? It is, so that is true by MVT, or sorry, by IVT, true by IVT. B is talking about the derivative. Derivative is MVT. Now I have to do some math. MVT states, I'll do this in yellow as my scratch work. MVT states that if I do the, I'm struggling for words, negative 5 minus 4, all divided by negative 2 minus 1. This is the slope. You do delta y over delta x, essentially. Our y's divided by our x's. We should get negative 9 divided by negative 3, which is indeed equal to 3. So MVT guarantees 3, not 0. So this one's false. False. That one's the answer. It doesn't satisfy MVT. F of C, this is true by IVT. And 3 is between negative 5 and 4, so that works. F prime of C, that's true by MVT. MVT states that it is indeed equal to 3 over here. And this is EVT. This is guaranteeing a maximum, EVT. The definition of this thing right here is a max. So the correct answer is B. Oh my gosh, we have 7 minutes. We got this. The graph of the function f is shown in the figure above. This is an exact copy-paste from the last test, I think. So we have an open dot here. You can't see it, and a closed dot here. Which of the following could be false, or which one is false? F of x is continuous at 2. It is continuous. It's just not differentiable. We have a sharp corner. It is continuous, though, so this one is true. B, the limit as x approaches 2 from both sides. As x approaches 2 from both sides, we do get a height of 2. So this evaluates to 2. The limit as x approaches 2 of f of x from both sides is 2. As I go to 3 from the right-hand side, I go to the same height, which is 2. So 2 does equal 2. That is true. Number 3, f of 3 is not defined. F of 3, there it is. F of 3 is 1, so it is defined. So that is false. Oh, sorry, it is not defined, which is true. It is not defined. Wait. It is defined, so this one is false. There's like a bunch of double negatives. F of 3 is defined, so that one is false. F of 3 is right there. It's 1. So the correct answer is C. Let's go through all of these. D, f of x is not differentiable at x equals 2. It is not differentiable because it's a sharp corner, so that's true. It's a sharp corner. It is not differentiable. This is saying it is not differentiable. That's true. F prime of 3 does not exist. F prime of 3 doesn't exist because it's not continuous. A bunch of double negatives happening in number 17. Number 18. Again, this is a copy-paste from the last test. Which of the following does the limit as x approaches from both sides exist when I'm talking about f of x? Both sides. The left and the right height go to the same height. Good. Left and right go to the same height. Left and right do not go to the same height, so it's only 1 and 2. Correct answer is D. Number 19, the slope of the line tangent. Every single time that I see this word, slope of the line tangent, immediately be thinking f prime. This is from our unit right now, from unit 2. When I'm doing f prime, I'm going to have to take the derivative. The derivative of natural log is 1 divided by x over 2. And then don't forget your dinner. Dinner is, well, the inner is x over 2, so the dinner is 1/2. The problem here is a fraction divided by a fraction. This is a keep, change, flip. If you can do that in your head really quick, it's going to be just 2 over x times 1 over 2. And then from here, the 2's are going to cancel out. I'm left with 1 over x. And I need to plug in x is equal to 4. Well, there's x, 1 over 4. And then finally, number 20. This is also a review from Unit 1. If I plug in 0, I get the indeterminate form 0 over 0, which means you're doing the following 3 steps. Name them.
Factor.
No, that's 3. Factor, cancel, plug in. So when I factor, I'm going to factor out an x squared times 5x squared plus 8. And on the bottom, again, factor out an x squared times 3x squared minus 16. That was the factoring. Here comes the canceling. Here comes the plugging in. I forgot my parenthesis here. When I plug in again, that was a bad parenthesis. When I plug in again, I'm plugging in 0 for x. When I plug in 0, that goes away, and I'm left with 8 divided by negative 16, which is negative 1/2. If these questions look familiar, that's because they're copy-pasted from the last test. They were the hardest questions. I put them on this test, or this pretest. The same thing is going to happen for the actual test. All right, ask me questions on anything. You have 3 minutes.